Okay. Oh, okay. Sorry, I think I was frozen there for a second. Hopefully that doesn't continue. Okay, so with respect to orchard floor management, I mean, what we're really talking about is how we're managing the soil. And, why do we need to manage the soil? Well, it's important to protect it to reduce soil erosion. We want to enhance drainage, to create a good environment, good, oxygenated environment for the tree roots. But then simultaneously, it's like we want good drainage, but we also want to be able to boost moisture retention and allow for some of that moisture to remain in the root zone and be available. We want to try to increase nutrient availability. We want to reduce salts. We want to try to control weeds and enhance the long-term sustainability of yield. So again, like as Wesley mentioned, I mainly work in almonds right now, but I think a lot of this is applicable to a lot of the crops that Mike was mentioning, whether it be stone fruit or apples. But I worked on producing a kind of like a guide with a lot of the concepts I'm going to talk about today. You can find it at that link, or you could Google the soil management resource with the Almond Board of California. But when we're talking about orchard floor management, a lot of times that's with respect to inputs that we're putting into the soil, whether that's cover crops, if it's regular inorganic fertilizers, if it's compost or straw. Um, but all of these different inputs, what they're doing is they're providing organic matter that has carbon and nitrogen in it of different proportions. And so depending on the balance, the quality and the quantity of those inputs, that's going to really affect what we call this nutrient cycling processes called mineralization and immobilization. So, and what we want in a healthy soil is to establish a balance between those processes. So mineralization, for nitrogen, it's the nitrification of an organic form of nitrogen being transformed to a form that's available for plant uptake, usually in the form of ammonium or nitrate, for example. And immobilization is when there's microbes in the soil that they thrive on carbon, but they also need some amount of nitrogen too. And so if there's a scarcity of nitrogen in the soil, those microbes might actually immobilize the nitrogen and taking it away. And so, but that immobilization also provides some nutrient retention in the soil. And so that's in a sense why we want to create a balance of both of these processes happening. And so when we have that balance, we're hopefully going to be maximizing the uptake that's available for our crops and reducing losses that you sometimes hear about in the form of maybe leaching or runoff, or there can also be gas fluxes to the environment. And so when we're talking about soil organic matter, it is a lot of different materials. Basically, that could be either living or dead and partially decomposed at all different stages. And so that's plant residues, roots, soil organisms. The microbes produce exudates that add that rich sources of material into the soil. And then there's also older and more slowly decomposing organic compounds that mix with the mineral soil, and that's what forms aggregates. And so aggregates is a desirable characteristic of soil that allows for the soil to have strength and holding itself together, but also allow for the flow of water and oxygen that supports healthy root system for our crops. And so this diagram is kind of showing a lot of the components that we would find in a well-structured soil with organic matter. And so some of the topics that I'm going to go through in terms of management today, I want to talk a little bit more about the soil, understanding the soil profile when we talk about the soil, so what it is that we're managing. And then if you're starting from the beginning with the planting, what are some things that you might need to consider in terms of soil preparation? And then I'm going to go over some distinguishing characteristics between cover crops, ground covers. Cover crops would be more annual, and ground covers would be more of a permanent or semi-permanent vegetation in your orchard or your yard. And then, what kind of value mulches and compost can potentially offer you. So when we're talking about the soil, really we can kind of break down the soil profile that we call the area where that the rooting depth of the majority of roots of, say, a tree in your yard would be the effective root zone. And so those roots are exposed to both topsoil and subsoil. And so the topsoil is where we have a lot of organic matter that accumulates. That's where there's all the biological life and the nutrients that are being supplied for those growing plants. And then deeper down into the soil, maybe below maybe about a foot and a half or two, depending on your soil type, when we start to get into the subsoil. And so these deeper layers are what really help control water movement and root penetration. And so it's important to kind of have an understanding of these type of characteristics of the soil that you're working with to make the best choices about what type of trees you may want to plant. Something else really important to consider, of course, is what kind of soil texture you have. Um, and again, like maybe information about how you've managed the soil in the past, or from a soil analysis, how much organic matter there is in the soil. And so these two characteristics, the texture. So when I talk about texture, I'm talking about how much sand, silt, and clay that you have. So if your soil tends to have more a sandy texture, you're going to have less water holding capacity compared that if you have a more heavier clay textured soil, we tend to see higher water holding capacity. And so, I know we don't have a lot of time to go into this, but, these are really important considerations to understand how much available water you have in that effective root zone that I mentioned earlier. And so in terms of like irrigating and watering your trees, you want to generally understand like how much water can I apply, or how much water can I apply in a single irrigation, and about how long is that going to last in the soil, before I have to irrigate again. And so with farmers, they a lot of times they use evapotranspiration as a means of scheduling their irrigation. So it's really useful to kind of understand, in terms of, here I have it is in terms of inches per foot of water, but there's different volume metrics to determine how much moisture your soil can hold. So if you are in a situation where you're thinking about replanting, there may be some things that you might want to consider. There could be replant disease. If you're in an area with really sandy texture soil, there may be issues with plant parasitic nematodes. If this is a replant where you had a lot of tillage or high traffic in the area, you may be dealing with compaction and drainage issues where the water is pooling at the surface. You may have either be fortunate to have high levels of organic matter, and good nutrient holding capacity and those things I was talking about earlier, or maybe your soils could, stand to have some improvement there. And then oftentimes, we deal with this a lot in California, and I remember from my time in Utah, I know at least in northern Utah, there can be some issues with salinity and sodicity that, you have an opportunity to kind of address these type of things before planting. So in terms of replant disease, now what this refers to is it's an issue when we replanted generally with the same or similar crop type. So if you had peaches and then you want to plant peaches again, or sometimes it could be similar plantings where you have peach. So, oftentimes use the same or similar parentage of rootstock as almond. And so, there can be problems there with planting one after the other. A lot of times this can be, not having a fallow period between plantings can add to these issues. And if your previous orchard had high level of mortality, there may be soil-borne pathogens or nematodes like that I mentioned that could dominate those soil microbial communities. So this can lead to poor root growth, and canopy development in subsequent plantings. So good to address if you can. So, prior to planting, you probably want to do some soil testing. And if you're in an area that's prone to nematode problems, you may want to do an analysis. And so some of the problematic nematodes include the root lesion, root knot, and ring nematode. Ring nematode is particularly bad for what we call prunus replant disease. So, understanding these soil analysis and the lab that does the testing can help you understand what those thresholds are and what that might mean in terms of the implication for treatments. I know probably soil fumigation might not be an option for a lot of smaller growers or in your backyard, but there are fumigation options. You may be able to use different types of cover crops or other strategies to help mitigate the issue. If you get a soil analysis and they come back and you don't see any of these problematic nematodes listed, then that means that it's not found and may not be potentially be an issue for you with replanting. And so in Utah, I found that there's some nice resources with more information about nematodes on the Intermountain Fruit webpage. So those links should be active if you want to look into more of that. Um, these are a lot of the type of soil sampling tools we use for different types of soil texture, but you can use, just a spade and shovel if that's what you have available. I think the important thing is to get representative samples from different parts of the field and to get the samples with depth. And so you would want to do different increments of sampling. And so this is not only going to be useful for, maybe diagnosing potential problems with nematodes, but also with understanding where you stand in terms of nutrition. So in terms of a chemical analysis, understanding where your soil pH is going to give you a lot of information about, the nutrient availability for your new planting and maybe how you want to manage it. So, Utah tends to have more calcareous, alkaline type soil. So, it's not uncommon for you guys to have pH above about a 7.5. And so that's where we tend to see problems with micronutrient deficiencies like iron and zinc. And but in areas where the pH is lower, usually lower about 6 or 5.5, we may see issues with phosphorus. And also, so even in a neutral range, which would be probably in about that 7.0 pH range, we can develop micronutrient deficiencies if there's not adequate amounts of those nutrients just inherently available. So soil testing can provide you with a lot of good information with that respect. Something else important to consider is compaction. So so this diagrams kind of show what is physically happening in the soil with compaction. So in a well-structured soil, about 50% of, if you collected a volume, say a bucket of, or if you had a cross section of some soil, about 50% of that would be soil minerals and about 25% would be just pores that allow for air movement, and about 25% of that would be water. And then a very small portion, maybe in an ideal situation, about maybe 2% or more would be organic matter. And so this is kind of the characteristics of a well-structured soil that allows, adequate movement for air and water to those growing roots. When you have a compacted situation, you're really kind of minimizing that pore size distribution and the ability for water and air movement. And so the roots just are not in as an optimal growing environment. And so we tend to see problems with vigor and growth in new plantings. So again, so that compaction, it collapses those pore spaces, impedes root growth, decreases the oxygen that's available to the roots, and can cause problems with water infiltration. So that can further compound issues because you don't want to create anoxic soil conditions for those growing roots. And it can, if the roots are compromised because they're not healthy, then they have a harder time taking up nutrients. And so if possible, it's good to avoid tillage. If you use tillage in your operation or other equipment traffic, when the soil moisture is at or above field capacity. And so I kind of glossed over it quickly earlier, but field capacity is considered that moisture that you have in the soil, maybe after you irrigated, that when it's not quite saturated, all the moisture, excess moisture is, drained away, but it's, just kind of that really nice moist conditions. So we actually want to avoid, those traffic operations when we have moisture that's in that field capacity or more moist conditions. So, maybe something good to keep in mind, if you're doing any kind of winter operations with pruning or anything like that, or maybe, in the off season, you just want to be careful. You want to ideally have that equipment out there when the soil is more dry. And then, so you can assess that. We don't have a lot of time to go into this today, but there's, simple soil moisture probes that you can have out in the field that can give you an idea of what your moisture levels are like. Or, there's ways to assess this with what's called the texture by feel method. And so you can use this texture by feel method. Just you could Google that, look up USDA texture by feel, and it kind of gives you a set of conditions to understand and assess, how much soil moisture there is in the ground. And another way that sometimes we talk about is, just kind of seeing like, is the mud sticking to your boots out there in the field? Well, if then that's probably an indication that things are too moist. If the dirt is just kicking right off your boots, then it's probably dry enough. Okay, and then just quickly to mention issues with sodicity and the effect on soil structure. And so when we talk about salinity and sodicity, so salinity is like the total composition of salts in the soil, but when the majority of those salt ions are composed of sodium, sometimes we have what's called sodic conditions. And so in a healthy soil that's, well aggregated, has plenty of, pore space for the air and water movement that I was mentioning earlier, the soil tends to be well aggregated. And in those situations on a chemical level, what's happening is that there's a good balance of different cations that hold soil particles together. And so we tend to have a higher proportion of calcium and maybe some magnesium. And so these cations have two charges, and so they tend to attract negatively charged soil particles, and so they kind of pulling them together. Whereas in a sodic soil or with sodic conditions, when you have the sodium, these are actually kind of larger ions in the soil. So they have what's called a larger sphere of hydration. And then they also only have one charge. And so they don't they tend to disperse soil particles away from each other because of the size of those ions, and then they don't have that dual charge that draws those soil particles together. And so that's on a chemical level, what's happening when we tend to see soils that look like this that don't infiltrate very well in our backyard. And there can be, so that's, emphasis on sodium, but just overall, when you have high electrical conductivity, so a high level of salts in your soil, pretty quickly, this can induce stress that can affect your tree growth and really decrease your productivity. And so yield declines have been observed at soil electrical conductivities above 1.5 decisiemens per meter and in irrigation waters above 1 decisiemens per meter. And so with respect to the soil sampling that I mentioned earlier, that's so if you're at the pre-plant stage and trying to figure out, is it appropriate to plant this here? The electrical conductivity or EC is something really important that you can use to evaluate that. So generally speaking, at least with almonds, and I think this would probably be true, for the stone fruits and apples, when you get above a level of 1.5 decisiemens per meter, that's when we start to see a decline. And so with almonds, for every one unit increase in that electrical conductivity, we see about a 15% decline in yield. So, just something to be aware of with salinity. And so there are, things that you can do. And, if you're at that pre-plant stage, or even if you have an established orchard, there are different various types of soil amendments you can use. And the idea with these is to provide a source of calcium that replaces that sodium that I mentioned earlier. So, adding calcium to the soil to help promote that flocculation of those soil particles. But it is really important to use soil and water analysis to determine what the correct type and rate of those materials are. And then, like I always like to talk with growers because there can be too much of a good thing. And so you want to, these amendments, they can actually be a source of salts that we're adding to the soil. So adding too much at once can do more damage than good. And so it can create what's called osmotic stress, which limits the ability of trees to take up water. And then also importantly, if you're using these kind of amendments, either pre-plant or an established orchard, you always want to make sure that you have adequate leaching water for that salt remover. So that is part of the process. You can't just, put these, apply this and stuff at the surface and let it sit. You need to apply water to adequately leach those. So I saw on the USU Extension website, there's a great resource that kind of explains a lot of this and, how to help you diagnose if you have a salinity or sodic soil conditions. So that's on the USU Extension site. And then, similarly, there's a guide called the Salinity Management Guide for almond growers. I think there's just a lot of great general information about, if you do soil testing, soil or water testing, how do you interpret that information and then use that to determine what type of amendment you want to apply and what rate. So other pre-plant strategies, fallowing is always, if you have the ability to fallow for some period of time, that is often a good cure-all for a lot of the problems that I just mentioned. I wanted to tell you a little bit about a process that we call anaerobic soil disinfestation, which is really very similar to, you may be familiar with solarization, that process. So that this is potentially something that you might want to consider pre-planting. Cover crops, also, especially cover crops that have a mix with mustard species, can help provide, a source of natural biofumigation that could help suppress some of those soil-borne pathogens and nematodes that I mentioned earlier. And then, I think that, Mike Pace, he mentioned, the importance of, doing research on these different root stocks. And so, you could ask if you're dealing with a problem with salinity, or if you have nematodes, issues like that, make sure to ask your nurseryman or consult with your your local extension agent on, what resistant root stocks are available. Again, the word is resistant. That doesn't mean that they're impervious, but there are some root stocks that may help mitigate some of the stress with those type of situations. And then again, those soil amendments, like I mentioned. So just to briefly talk about this anaerobic soil disinfestation. What it is it's a non-fumigant pre-plant soil treatment, and the idea is to suppress these soil-borne pathogens and nematodes by creating temporarily anaerobic conditions. And so this is really what distinguishes this process from solarization. Solarization is very similar, but the idea is to suppress those pathogens with heat. And here we're adding a carbon source into the soil, and then placing we're irrigating it, making sure that we're getting that moisture to those field capacity conditions that I mentioned. And then we're going to cover it with a plastic tarp. And what we're doing is that we're allowing the microbes that are in the soil to consume oxygen and create these anaerobic conditions. And then these the byproducts of some of this microbial activity that happens in this environment suppresses these pathogens. And so usually this process takes about 3 to 6 weeks, probably depending on, what time of year you do it and what the outside weather conditions are like. But this could be, a helpful approach to, if you have concerns about planting a peach after a peach, or if you know that your field has a history of nematodes. We're finding with the research that we're doing out in California that, that this is, gives comparable results with a traditional chemical fumigation. And so in the picture here, what we've used is we have a lot of wood chips readily available out here in California, but there's various different agricultural byproducts that you could use, but wood chip seems to work really well with this process. Okay, so moving on to cover crops, mulches, and other organic inputs. And so what these inputs are providing, again, you might remember that first slide I showed with the nutrient cycling diagram. Is so we're trying to influence that balance of carbon and nitrogen in the soil. And these are two, really key elements to sustain that biological activity. We want to provide cover for the soil. We're often getting these intense rainstorms often now, especially out here in California. And I think that's true for you too in Utah. But if we can protect the surface of the soil, then you know we can prevent some of that dispersion that causes problems with infiltration later. Um, and so we're going to help with infiltration and increase water holding capacity. And then a lot of times, some of these inputs can also provide a source of nutrients that might be either could be a partial substitute for your traditional inorganic fertilizers, without impacting your yields. So a lot of times people are concerned, especially out here, about, well, is that going to increase our water use? And, to have a cover crop or of some kind. And one recent study out of California, it was kind of like a review of a lot of the research that's been done, but basically found that our winter cover crops, annual grasses, legumes, and mixes tend to have similar water use as clean cultivated soils. So, we think that that it's because the cover crops provide that cover for the surface. It's like, yes, you are having more evapotranspiration from the cover crop, but you're also allowing for moisture to penetrate deeper into the soil with infiltration, and so that's where you're kind of getting that enhanced water balance. There's this nice tool that was put out by the Western Cover Crop Councils, I think in cooperation with NRCS and other organizations. And it's this nice cover crop selector. So you can go in and select your state. You can enter all kinds of information about, what kind of crop you're intercropping it with. The more information that you feed the tool, the more precise its recommendations. And so here's just a screenshot of things that came up with yesterday. So just looking at various different cover crops, and there's a lot of good information about what the rate might be that you might seed that at, maybe what kind of beneficial insects it might attract, time of year of planting, and all that good information. So I think it's a tool really worth investigating. In terms of preparation for seeding for cover crops, so this might vary a little bit for you with different winter conditions, but maybe, in the southern part of Utah, maybe this is applicable, but we tend to do our seeding in the fall, and we plant about a 1/4 inch to a 1/2 inch deep, usually about the end of October or early November before we get some fall rains. Generally speaking, a no-till seeder is the best option, but and what you want to do is you want to, if the soil surface is hard, you want to just, prepare that top 1 inch of the seedbed using maybe a disc plow or a rototiller to loosen that soil surface. And then this is just a picture of a tractor mounted seeder going through an almond orchard. And so, depending on the size of your equipment, the size of the seeder, you may be able to fit 2 passes in to get as much coverage as you can between trees. Something that we see sometimes, a lot of our orchards are, we just use micro irrigation along the tree line, and so if we haven't had those fall rains, we'll tend to see the cover crop emerge where we have irrigation. But generally speaking, as long as you get consistent amount of precipitation, that should give you a pretty even stand. So this can be a little bit of an issue more so in the southern part of the San Joaquin Valley where I am. In the northern part of California, they get more consistent rain in the fall, but this is why there's some hesitation with the cover crops, is that it's sometimes hard to get a uniform stand if you're just relying on that micro irrigation on the tree line. Some different types of cover crops, might depend on what your objectives are. If you really want to get as much nitrogen from this cover crop as possible to supply to the trees, then you might use a green manure mixture. And so these tend to be large seeded cereal grains like oats and barleys, all planted with these nitrogen fixing legumes like vetches, peas, bell beans, seeded in the fall. And then we cultivate and mow them in the spring. And then that releases that plant available nitrogen when we terminate it. Um, there's some other these annual reseeding legume species. So instead of terminating it and seeding it again, there's a number of species that will produce enough seed that they'll create their own seed bank where you wouldn't have to continue to seed them continuously. And so that might include a lot of these type of clovers. When I was in Utah, we were doing a little bit of research with Burr Medic, which was very prolific. But it can you really want it to just seed it or just have it where you want it established, because it can be quite prolific and take over. And so, in terms of that green manure cover crop management, again, we tend to terminate it at early flowering. That's going to give you the highest nitrogen content if that's what if your goal is in producing this cover. Um, and and also terminating at this stage, like this, if you have a lot of excessive moisture, if you had a lot of precipitation, say in the spring, these cover crops might help remove some of that excess soil moisture without necessarily depleting the soil reserves. So here's just an example of some reseeding grass species, some trials that we were doing in pistachio, looking at what's called blando brome. And so that seems to work really well for pistachio growers. So that's a lot about annual seeding cover crops. This table just kind of shows you a comparison of what the benefits and drawbacks might be compared to a permanent ground cover. So, the annual cover would be seasonal, a permanent would be year round, or, lasting over multiple years. The primary goal with an annual cover crop might be to, just do some soil improvement or provide that, that quick plant available nitrogen. Whereas that permanent ground cover is, kind of contributing to that long-term stability and structure of the soil. Um, uh, Depending on what species you select, there's going to be differences with water use, of course, and the nitrogen contribution. If you have an established ground cover, you're going to have you're going to be disturbing the soil much less frequently. And something to consider with the management of, like, say, these permanent ground covers is that you probably are going to need to mow it, but you need to be careful depending on the species how low you mow it, because that might affect its ability to redevelop the stand. So this is an example of some permanent ground cover species. There's perennial ryegrasses like fescues, perennial grasses like fescue and ryegrass. There's low-growing legumes, white clovers, trefoil is a favorite of mine. That's what I did a lot of research when I was in Utah. Or you can look at a mixture of grasses and legumes. Sometimes that diversity provides, different benefits in terms of how they root in the soil and how they affect the movement of water and how they affect the nutrition. And again, sometimes you can just get away with just managing resident vegetation. So just managing whatever, is coming up naturally on its own in the orchard. There's still going to be a lot of benefits there. So I was just going to tell you a little bit about a research trial that we looked at in organic peach when I was in Utah. And this was at the Kaysville Research Station. And these black circles were, where I understood that, there was some peach production. But, as Mike mentioned, the majority of it is here along the Bonneville shoreline. And then, there's also some up in the Kaysville area. But we looked at a number of different things. We looked at having a permanent grass versus a legume alleyway, and then looked at what happens if you allow vegetation to grow in the tree row where the trees are, or if you use like a straw type mulch in the orchard. And so we had starfire and coral star varieties on level rootstock. And this was again at the Kaysville Experimental Station. And then that legume alleyway that I mentioned was that bird's foot trefoil, the Lotus corniculatus. And again, what these legumes do is that they form a symbiotic relationship with nitrogen fixing rhizobia, and so they provide a source of nutrition and oxygen to these soil microbes, and in return, they fix nitrogen that's available for the plant. And so what we did in this orchard is we used what's called this mow and blow system. And so when we mowed the orchard, we'd actually blow the residues onto the tree row, thinking that as it decomposes, that's going to be, really available for the tree to uptake. But something that we did, and is common, I think, in these organic systems, is we use this sandwich type system where we actually had a very narrow tillage strip, where if you need to apply other fertilizers, you may not just be relying on a cover, you need to probably provide some more supplemental fertilizers. We would apply them in this strip so that it could be more easily accessed by the tree roots. And so that tillage strip was just a very shallow tillage where we just lightly incorporate, say if it was compost or some other type of, this was actually an organic peach orchard. So this was the system. We looked at all kinds of things about how the tree roots grew in those different treatments that I mentioned. And what we found was that when you had a trefoil or a legume alleyway, again, these are permanent compared to grass, which I think is probably pretty common there. I used to see a lot of that in orchards in Utah. We actually found that you got more root biomass, and those roots, were larger with the grass, with the trefoil compared to the grass. When we had a straw or a living mulch, they definitely ended up having higher root mass compared to an orchard that just had tillage in it. But there was not a lot of difference between those two treatments in terms of their effect on root growth. I know I'm probably limited on time, so this is we did an analysis that there's ways to measure nitrogen in the tree leaves that'll tell you that where the nitrogen, give you a good approximation of where that nitrogen came from. And so we use what's called natural abundance isotope analysis to see if the source of nitrogen that the trees were getting that were planted with trefoil it was in fact coming from those legumes. And basically that's what we found, is that there was different levels in this what we call natural abundance of nitrogen. So very interesting kind of finding, and actually working with my advisor Jennifer Reeve, and hopefully getting some of this still written up. It's been a little while, but we're still working on it. And then we also looked at a lot of different things to do with soil nutrient cycling, but long story short, we tended to find higher levels of available soil nitrogen in the treatments that had the trefoil. Something else, to consider, like I said, maybe you have access to a lot of wood prunings and things like that. These wood chips, it does miracles for the soil. I mean, it's just amazing what a wood mulch does for the soil. We have a lot of issues, with compaction in our high trafficked orchards out in California. It reduces what we call bulk density. So if you remember, I was showing that compaction diagram. When you reduce the bulk density, that means you're increasing the volume of soil pores for the air and water movement. So both when it's applied either as a mulch or lightly incorporated into the soil, we found those results. We've also looked at things like water infiltration. And so, applying wood chips in an orchard or even just along the berm, we tend to see that the water just goes into the soil better, and it tends to increase our soil moisture holding capacity. And so this is just some analysis that we did comparing, control soil with no wood chips compared to soil with wood chips, and just seeing how that affected how long the moisture stayed in the soil. And we were seeing some differences there. Okay, I'm just going to wrap up talking about compost real quick. So compost can also have impacts on soil moisture and tree water stress. There was a study done by a group out of UC Davis, and they looked at using compost in almond orchards, and they tracked the soil moisture content, and they looked at stem water potential, which is an indicator of tree water stress. And they found that the trees with compost applied tended to correlate with lower water stress and greater water holding capacity in that 2-year study. But something that important that I just want to mention is that if you're using compost, it's important to understand that not all of that nitrogen is necessarily going to be available. In the first year, you may only be getting maybe 10% of the nitrogen that you see if you get the compost analyzed. So this table just shows, maybe what some of the important things that you might want to consider if you do a compost analysis. Am I running short on time, Wesley? Sorry. You want to know about what your percentage of nitrogen is. You also want to get an idea of what the salts are. But basically, what this table shows that for if based on that percentage you applied 366 pounds of nitrogen, you might only expect to get about 36 pounds of that N. And so my email will be at the end. So if you're curious about this, please email me and be happy to walk you through that calculation just to help give you an idea. So compost is going to apply some nitrogen, but maybe not a significant portion of that. Okay, so in summary, if you're trying to understand orchard floor management, you want to start with the soil profile. And effective management requires understanding the physical properties, the chemical and biological constraints that you might be looking at. If you're in a pre-plant stage, that anaerobic soil disinfestation, biofumigation from cover crops, selecting resistant rootstocks and targeted soil amendments might help address any of those concerns you might have. And then in terms of orchard floor management options, there's annual covers, those green manures that support pollinators, they improve the nutrient cycling. Those longer term ground covers provide more continuous soil cover and help with erosion control. Didn't get into it, but there can be some downsides with vertebrate and insect pest pressures. Also, that cover requires mowing. Mulches reduce evaporation. They help moderate your soil temperature, suppress weeds, and improve the soil moisture. Compost may help improve soil organic matter, but don't count on it for a large nitrogen benefit. So there's my contact information. I'm really sorry for running over.